So let's begin with what the ACI Anywhere vision is. I was pleasantly surprised to find out that most of you knew what ACI was, so that's a good beginning. But the way that ACI has evolved in the last few years is we started as an ACI as a data center fabric, a data center implementation. And over the last few years, we have gone to something called MultiPod, then we've gone to something called Multisite. I will swear, there's no sign for no swearing. But there's Multisite, then we added some things called remote leaves, and I'll cover all of these things. And these are all things that we're shipping already, and then I'll cover the way we're talking about multi-cloud extensions. So we're also moving ACI into AWS, Azure, and Google Cloud. So there's sort of a vision for us to of having security, analytics, and the same policy across all these different environments. And that's what the ACI Anywhere vision is to me. And so I'll cover how we're planning on doing that. So let's talk about what's shipping already. When we built an ACI fabric, the first implementation of it was an on-site single data center implementation. But we had certain customers that said, you know, I have a lot of fiber, and I'm going to interconnect a spine leaf architecture between two locations. And then some of them said, well, I don't have that much fiber. How do I interconnect multiple locations in a metro area and make them seem as a single data center? There are multiple reasons for that. Virtualization that allows you to move VMs around, disaster avoidance, really, because if it's in the same metro area, and some upgrades and things like that. And so we came up with this concept of MultiPod. What MultiPod is basically taking that ACI data center fabric and putting it across multiple physical locations, but having a single single management plane. So in ACI, we use the APEC as our management plane. In a multi-pod environment, we have a single APEC cluster, and we can deploy the pods across different locations. That's also a way of growing the ACI fabric. We would like you to keep the pods to 200 leaves. So if you want to grow very large, we want the control plane to sort of stay localized. And that multi-pod allows you to have multiple control plane domains with a single management plane. So what that allows us to do is, if you have an IP network between two locations, and the locations are within 50 milliseconds latency of each other, it's like managing a single data center. The configuration changes you make in APEC get pushed to both sites, or both pods, actually up to 8 pods, and we will run MPBGP VPN as a control plane and VXLAN as an encap between the sites to stretch your network. So you apply policy in one place, it exists across all your sites. Or pods is really the word I should be using. So that's our multi-pod implementation. Single management plane, multiple control planes connected by an IP network. But then our customer said, you know, maybe I want to have the stuff a little farther apart. Maybe I want to have separate availability zones. So a while ago, we also shipped something called Multisite. Multisite is a bit different. In Multisite, every site has its own set of APECs. So every site has its own management cluster. And then the underlying infrastructure is managed by that management cluster. And then we have a concept of local and global objects. So we can stretch networks and policies across multiple domains. And we have what we call the multi-site orchestrator as the tool, as a cluster of VMs that manages all these sites together. The multi-site orchestrator configures the intra-site connectivity. Again, MPBGP VPN with a VXLAN data plane. And it allows all the workloads to migrate between sites if necessary, or subnets to be stretched across the site, the policy to be the same over a regular IP network. The upside of this is now we don't have any delay requirements, right? 1 second latency is basically around the world. So the question is, what's the right use case for stretching subnets if you have to? But certainly there's a good use case for stretching policy, right? So this is Multisite. Multisite has some other things that we do inside it where we can also allow you to advertise a VM, because that's what you're really moving between sites, address from a specific site. So we can make sure that your in and out traffic is always symmetric. So you vMotion a VM between sites, the VM arrives on a new site. I have the capability of advertising that /32, that host route out of that site, so that when the traffic goes in and out, it will go in and out of the same site, which allows you to just deploy physical or virtual firewalls and keep that synchronous traffic pattern. But the key really is that we have a single policy domain that works across all of these sites. And so, to give you guys an idea, right now we're up to 10 sites managed by a single MSO domain with 1,000 leaves. So that gets quite large. Release 3.1 and Release 3.2 have already been out. We're now talking about Release 4.0. And in Release 4.0, we get a couple of extra capabilities. In Release 3.2, which we're shipping, one of the things we got was that MultiPod concept can be considered a single site from a multi-site perspective, right? So now I can have 8 pods from a single management domain, and I can deploy it as a single site, and I can manage it all from an MSO perspective. And this is important as we move forward on what we're doing. So all of this is already shipping. In 4.0, we get something called CloudSec, an L3 multicast, which is basically TRM, multicast over VXLAN, which we are also having in NXOS, a few other features. But the reality of it is that 4.0 is coming very soon, and CloudSec is one of the capabilities where we can actually use our hardware to create encrypted tunnels between your sites at line rate. So when will 4.0 be released? Brianna was wondering about it. She asked me if I was going to do. And so now for geek points. Name the movie.
Baseballs.
What was the question that came out of this scene? When will then be now? And what was the answer? Soon. So 4.0 is coming out very soon. The official stance is this quarter. So when will then be now? Another thing we shipped fairly recently is what we call the physical remote leaf. This is a slightly different integration to the MultiPod. In this case, we have customers that are like, hey, I just want to get 2 leaves out to a colo, or I want to connect 2 leaves to my existing network and make them part of my ACI fabric. So what happens here? Basically what we do is we don't need the spines anymore in these colo locations or this other parts of your network. Those 2 leaves connect to an IP network. They get seamlessly configured, just like you would if you connected a couple of leaves into your ACI fabric. And they have all the same capabilities. I want to repeat that. All the same capabilities. So today, we can do 20 sites off of one ACI pod. What happens is the leaves connect directly to the ACI fabric over an IP network, again, using EVPN and BGP, MPBGP VPN and VXLAN. And from a management perspective, those leaves may as well be connected to your fabric physically. Right? So for colos, small offices where you may want to extend your DC, some of our SP customers with 5G, it makes a lot of sense to have a single fabric managed by one set of APECs that literally has the same policy and networking across multiple domains with an IP network between it.
This is really just about the management, just to stretch, because obviously it's not topologically got anything to do with leaf spine in this case.
Right. So there are a lot of, so without getting too deeply into the things, there are a lot of things that happen in the spines. We run something called a COOP database, which is all the endpoint locations and all that stuff. Having to deploy spines to get a full forwarding table on a colo that needs 2 leaves was sort of painful, right? So we sort of withdrew the spines and made this work without them. right? So a little bit more information, right? Then of course, just like they were physically connected, we pretty much get all the same capabilities that we would have on connected leaves, on this remote leaves. You can connect an L3 out to it. That's the in and out traffic for the data center. So you can go in and out of that specific pair of leaves. You can do service insertion. You can do VPCs. You can connect faxes to them. Pretty much anything you can do in a regular set of leaves that are connected to your fabric, you can do here. A couple of interesting things that you need to be aware of. We changed the forwarding algorithm a little, right? So one of the interesting things you have to realize is if you have single connected devices on those two leaves, leaf 1 has endpoint 1, leaf 2 has endpoint 2. In the regular network, you'd go to your spine and back down to the leaf. In a remote leaf pair, we'll do local forwarding between the two leaves, right? So you don't have to go back to your data center to come back around, right? So you can do what we call greedy forwarding in the same sites. So that's a slight change. There are a couple of other things that, frankly, we don't need to cover here. But I'll spend a little time on how this works because it sort of fundamentally adds on how we keep going to the ACI vision. And so when we deploy the remote leaves, there's a wizard inside your regular APEC. The important things you have to realize is you have to assign those leaves a IPPat pool, right? So the tunnel endpoints that you're going to use for the VXLAN configuration, you have to basically create a pool of addresses that we advertise to the outside world, to the WAN, basically, that are going to be the addresses for your APECs and the addresses for your spines. They're going to be the in and out connection for these pods. So what happens is when you first create the remote leaf configuration, you say it's going to come from this subnet, right? So it's a DHCP request. You give it an IP address, and you give it a tap pool that is going to get advertised into OSPF so that we have the automatic reachability between the remote leaf and the local devices, right? And so it's literally a form you fill out. And when the leaf first comes up, there's certain expectations, right? So your upstream router is going to have DHCP relay enabled on it and OSPF. The other things, because it's zero-touch provisioning, is we expect it to be on VLAN 4. We picked one, right? Okay. The VLAN 4, frankly, is only locally significant. You can still use VLAN 4 on the front-end ports. The idea is I do a DHCP discover on VLAN 4. I expect that DHCP is going to give me back the IP addresses of my APECs, right? And that those APECs are reachable, again, that subnet that I created up front, by the local routers. And again, the encap is .1Q4, right? What happens then is the DHCP request, it gets relayed to the APEC. The APEC will send back your IP address, because we predefined that, and a bootstrap file that basically says this is how you connect back to your spines. Once you connect back to the spines, right now you have an IP address, you will get your code, all the things that happen when you physically connect the leaf into your fabric. And once that's up, basically the leaf is just another leaf in your ACI fabric, right? The only thing you'll know different is the role is going to say remote leaf, and the IP, the tap pool IP, will be coming from the tap pool that you assign to those leaves. It's not going to be the local tap pool, and that has to be a routable address, obviously. So again, fundamentally, we're building ACI outwards.
You're actually going to keep that OSPF adjacency up, and that's how he's going to know how to get to that remote IP.
Exactly. So when I first created that form that I filled out, those are the addresses I'm going to advertise from my spines into my WAN, right, into my core, whatever you want to call it. And that's how we know how to get back and forth.
So we don't have to tunnel. We don't have to do.
We'll tunnel automatically for you. We'll do the VXLAN tunnel automatically. Now, I don't know if you caught it, but to get a little geeky, we have a higher MTU here. You have to take into account that you're going to have VXLAN VXLAN overhead. You don't have to, right? You can set the MTU on your front-end ports, but I mean, I kind of glanced over because this is not network field day, so I didn't want to get over into the technical details of it. But again, from a management perspective, it's literally like if it was there, right? Even though it's in a remote location. Oops, sorry. So, how do I go backwards? So again, in 4.0, which is coming out soon, we got a few other things. One of the things that some of our service provider customers were interested in is doing inter-VRF local switching. So if I have multiple VRFs on my leaf, I don't want to come back to my on-prem and back. Again, this is not for many people. It's for some. And then, of course, we're now up to 32 remote leaf pods or 64 leaves on a single pod. So now think about it. Technically speaking, you could deploy to 64 locations and manage them as a single one.
And I see that CloudSec turned into MaxSec.
So CloudSec.
Sorry.
So CloudSec and MaxSec. MaxSec is for the front-end ports. CloudSec is actually connection back to the data center. We pushed CloudSec out. So CloudSec is coming out for vanilla ACI connections in 4.0. We pushed the QA effort. There was not enough requirement for it yet. Yeah, but that's If your switch is capable, it's going to it can do it. Yeah. So then, now to something a little different. Our friends at VMware closed out a couple of APIs on us and drove what used to be the Nexus 1000V and AVS out of the hypervisor. So we always had a plan of being hypervisor agnostic. This just brought the plan into fruition a little faster. So basically what we have now, and it's shipping, is what we call the Cisco ACI Virtual Edge, or the AVE. I'll spend a couple of minutes on what that is and how it works. But the bottom line is we have a transition migration from AVS to AVE that's automated. If you want to go from AVS to AVE, our AVS customers are already doing this. And then we're going to have I have to be very careful how let's just say it's going to have the same feature set. I'm going to leave it at that instead of going into too much more detail than that. The idea is this, right? So it's a CentOS VM. It runs in user space. By default, we use DPDK. And what we'll use the regular VDS to drag the traffic into the inside interface of the AVE. And then we'll tunnel the traffic out of the outside interface of the AVE, just like we did with AVS. Instead of happening in kernel space, now we're doing this in user space. You do not have to take all your VM traffic through it. You definitely don't take your VM kernel traffic through it. The capability is there to let our customers go to this model, and it's also hypervisor agnostic now.
Which means I can do this on Hyper-V as well?
Very soon. Okay. Yeah, not yet. Again,
and it's not really agnostic, is it?
Yeah, that's fair. Not today.
That's your intent.
What's that?
That's your intent, right?
Yes.
Yeah.
Yes.
Okay.
Are you using AVE to achieve the same on the public cloud side as well?
I'm getting there. So we're going to get to the next level. So a couple of things, because it always comes up. We're seeing pretty good throughput with the PDK enabled. Is it as fast as being in the kernel? No. But it's almost line rate on a 10 gig box. Scaling is pretty good. And it allows us to do a lot of other things that I can't talk about because now, so not that this is ever committed, but if I wanted to, I can run a container in my CentOS box. And I can run many services inside a container, right? So there are capabilities that we didn't have when we're inside the hypervisor that we're going to have now. I think I covered most of this. The important thing for you guys to keep in mind here is that AVS and now AVE use an OpFlex control channel between the leaf and the forwarding engine, right? Basically, that OpFlex channel programs is the control plane. Let's just leave it. Let's just put it at that. There is a reason I'm pointing this out, because as we move to the next version of features that were coming out soon, it will make a difference. So all of this, AVE including, is already shipping. Customers are using it, and everybody is happy as far as I know. So now, coming to the things that you guys were asking earlier, in 4.0, which is coming soon, we're going to have limited availability on something that we call the Virtual Pod or vPOD. So vPOD's a little bit of a different animal. It's also meant for bare metal clouds and colo locations where you own your hypervisor. But in this case, we take the spine and the leaf from ACI and we turn it into software. So the spine construct and the leaf construct are now an OVA that I can deploy locally. And what's happening is that I can basically take that connectivity, that same way I was addressing my remote leaves, and I can now address my virtual machines and allow them to connect to my APEC cluster. So what happens? In a virtual pod, I will deploy these VMs, a virtual spine and a virtual leaf, which basically have the exact same code as we would use in the physical devices. The vSpine and the vLeaf become the control plane for all the ACI functions. So the spines connect back to the data center just like a pod from a virtual pod spine would connect back. They talk COOP, all the things that happen there. The slight difference is now we use the AVE as the forwarding engine. So you have a cluster of spines and leaves, right? 2 of each if you want to have HA. Those leaves speak upflex to all the AVEs and the hosts that are local, and the AVEs forward just like they would if they were a physical device. So we sort of abstracted the entire forwarding engine, all the control plane, from physical to virtual, so you can deploy this remotely.
And with no hardware dependencies on whatever the local networking equipment is.
Exactly. So we made ACI software, right? But again, from a pod perspective, right? This is part of a pod. It's not its own site,
Okay.
right? So that brings us to Cloud APEC and our plans for the public cloud. So Cloud APEC. Cloud APEC is the way we're we're going to go into the cloud, right? So the native cloud. It's basically a virtual form factor for APEC. It will translate ACI policy to native cloud constructs. And it's obviously going to be northbound APIs. I'll give you a little more detail on how this works. It's going to have the same similar feel and configuration as a regular APEC would. So the idea also is one more thing that I wanted to come over. The Cloud APEC cluster will manage so the first deployment is going to be AWS. It's going to manage one or more regions in AWS. Right, so cluster for multiple regions. And the idea is, in the bring up, I'm going to go over this very quickly, is you're going to fill out a form. The form is going to have CIDR addresses, external addresses, internal addresses, your account for AWS and all these things. And when that goes out, it's going to create its own infra VPC. It's going to configure internet gateways. It's going to basically set up an AWS VPC so you can use it as soon as the Cloud APEC gets deployed. The Cloud APEC is pulled out of the Amazon marketplace. So everything is automated. In about 5 minutes, you're going to have a VM, an instance running on AWS with a public IP associated to it, right? So no magic there. Lots of people can do this. The difference is then you can connect into the Cloud APEC and deploy the other 2 APECs and create a cluster from there. It's going to literally just be a next kind of thing. And then Cloud APEC will deploy a couple of, one or multiple CSRs, so cloud services routers that already have been around on Amazon marketplace for years and years and years and are well known. And also will connect those APECs to MSO just like you would connect the APECs from a separate site. So now, multi-site managed by MSO, this just becomes another site, right? The other thing we'll do is then we'll configure the BGP VPN configuration to connect back to your on-prem. It's going to create a VXLAN tunnel for your data plane. Now we can do this over direct connect or the internet, VPN. You pick your, no magic there. But the interesting thing about this also is that Cloud APEC will also register with Amazon services and pull simple notification services, config services, all the things that you may be interested in, right? So it registers as an admin account. There's the appropriate account to get all these notifications. So moving on, the other thing you'll do is if you have VPCs that are already in your account, you can connect them into your infra VPC that we just created. We'll deploy either a CSR or a BGW, your choice. The default right now is BGW. So the Amazon construct, the VPN gateway. And these devices will then establish a VPN or IPsec or GRE tunnel, depending which one you want to use. Well, it's only IPsec if it's BGW, to your infra VPC.
It becomes a transit VPC at that point?
It becomes your infra 1 VPC from a multi-site perspective. So you have a VRF, when you create multi-site, it's called the infra 1 VRF, that connects all the sites together. And that's basically what this is. That's what basically this is. Again, in multi-site, frankly in MultiPod as well, but it's slightly different. Your spines connect on IPN, right, IP network, and then you talk MPBGP VPN and create a VXLAN tunnel between the spines to extend your networks.
And the end game here is just policy consistency. I can now push APEC policy all the way into AWS. And the key there, you said early on, there's a translation that's happening between APEC policy and native AWS construct.
Come on up here, and that's exactly what it is, okay. Right? So the reality here, just so we're clear, is day one, this is coming out in 4.0 as a very limited availability alpha, so for a bunch of our customers that are very interested, and 4.1 as GA, so very soon in alpha. Our customers have a few things that they want to do, but on the first iteration, we're not extending L2. Extending L2 from your data center to your cloud is dumb. I'm just going to put it that way, right? I know people want to show you vMotion, live vMotion between your on-prem and the AWS. I call BS on that for a real use case. There are a couple, but not much.
I mean, so, this is a compute or resource-heavy kind of a thing to deploy in the cloud. Is there a efficiency concern there?
From what perspective?
Well, you're running a bunch of CSRs, you're running APEC controllers and all that stuff, a lot of CPU.
Right, so a couple of things that I need to probably qualify, right? We will not deploy the BGW or CSR unless you need them. So let me step back a little, right? The infra CSRs we're deploying, right? Because that's your intra-connection between your on-prem and the native. Now, if there's no need for VPC2 here to ever talk to anything else, it's doing its own thing, it's QA or whatever, and never wants to connect back through this tunnel, we will not deploy a BGW or a CSR for it, right? I will cover how that works a little bit later, but yeah. And again, the default is BGW. You get more capabilities with CSR, obviously, because it can do a PBGP VPN, Lisp, all types of interesting VPN connections, blah, blah, blah. And also, just so we're clear, right? And that's why I added the AWS subnet router. The way the flow works is AWS doesn't let you just use CSR as your default gateway, right? The way AWS deploys it is you have to use their subnet router. The subnet router will send the traffic to the CSR, right? So if you need to go to S3 here, or pick the AWS native service, you hit your subnet router, and you go to wherever that is. If you need to connect back to your data center or another VPC that's yours, then it's going to go to the CSR or multiple CSRs of BGWs, right?
Is the alpha just AWS, or does it include other clouds?
It's AWS first. So more details. What ends up happening is back to the same. Nobody saw the premise yet, huh?
Well, I saw premises on the last one.
I know that one says premises, yeah. So the whole idea here is, looking at that vision, AWS, in this particular, the first alpha release, becomes a site just like Multisite. So the bottom line is MSO, the Multisite orchestrator, becomes the manager for that. So what does that mean? First of all, we're going to kind of, if you're already familiar with ACI constructs, it sort of translates them, right? Just like Ethan said, you know, a tenant is a user account, a verb is a VPC, a contract security group rule. I mean, there are very, very, very easy commonalities there, right? So just like Ethan said, translating them is the key. And then, of course, there is the policy mapping in AWS for IAMs and availability zones and infra VPCs. The infra VPC is exactly what we were talking about earlier. That's the VPC we create to do the overlay, right? The ACI infra. That's mandatory to get that connection. And now I have 5 minutes. So just like Ethan mentioned, what that means is from MSO, I push the policy down. And on-prem, it's EPG web, contract, EPG app. In AWS, it's security group web, security group rules, security group app, right? And the policy where it says, OK, my databases are always on-prem because I don't want to put them into AWS, but my web and app are on AWS, that policy domain is pushed and it's consistent. And you can do audits on it and all the good things that happen with that, right? And so the other thing is, how do we do endpoint learning, right? Early on, I told you guys that we subscribe to a bunch of services. The config services, when you bring up an instance inside one of your VPCs, AWS will notify Cloud APEC. Cloud APEC will apply the policy that's relevant to that instance. The default, but changeable policy is, we're quarantining you. I don't care what you want. Unless you're tagged correctly, you cannot talk back to our data center, right? And no one can change that except for specific admin users, right? So the idea is you're automatically secured as far as connecting back to your own data center. And then we can use subnets to apply to an EPG. So if we create a cloud EPG, the subnets can be across multiple IP subnets. And we'll apply the same policy across multiple availability zones, regions, so forth. Or you can tag the VM, right? So that's what 99% of people do. They apply the correct tags to the VM. If the right tag is applied to the VM, the instance, then the right policy gets applied automatically. I'm going to take an extra 5 minutes. I got you. So that's sort of how we apply policy across multiple sites consistently, right? So what does that mean? So when we manage using MSO, if I create this is MSO UI right now, I'm cheating a bit here because I don't have an instance, I don't have a site that's AWS. I wasn't allowed to. But the bottom line is you just add the sites as you would any other site. AWS would become a site. You create two EPGs and you connect them together. When you deploy them on-prem, it's going to look cloud, hybrid web, contract to hybrid app, right? On AWS, if the instances happen to be in the same VPC, we'll program the policy so that they can talk to each other in the same VPC, right? AWS is a whitelist model. Now, if the instance is across multiple VPCs, we will program the routing and the security so that the communication happens automatically. You don't have to worry about that anymore. And this is more complex than you think it is. This is
we think it's complex
to do in AWS. This will be automated for you, right? So literally, you're going to drag web, app, put a connection between them, both stitched together for you through the infra VPC. For routing and policy-based routing if necessary. The point of, if I add a security, service graph, and I'm showing you how to do that service graph, it becomes a service graph on-prem. But if I have a service VPC, if I deploy a service VPC, which is the only way to do it in AWS, and I want to deploy my FTD, my vFTD, or my other service VMs in there, I will drag the traffic. So I will do the policy-based routing so that this happens automatically.
Taking a step back from the complexity of how the communications are actually happening, I think a bigger message here is that if you are invested in APEC and managing your traffic flows in that way, you're able to continue using that tool in the public cloud now, meaning in theory, it's actually easier because ultimately you don't have to care about that fancy slide that's happening right there.
Exactly.
You really don't
This
need
is
to know.
very complex to do, right? In MSO now, it's literally drag and drop, and it just happens, right? There's a ton of stuff that happens in the back end to make this happen, right? The other thing that's difficult is this. All the cloud native advanced fault stats that you have in AWS, we're going to consume them in Cloud APEC. We're going to APECize them, right? We're going to flip them into a model that makes sense. We're going to put it into our object model. And so you're going to have a single visibility from a network and security perspective for your entire, I'll call it data center, but it's not, right? It's your entire cloud. And that's also a big part of it. This is difficult to do, right? The cloud audit events and all that stuff, consuming it and pulling it into the tools you have on-prem is difficult. We're going to simplify this for you. So we're going to normalize that into an object model that you already understand, or at least a ton of tools already understand as well. Okay? And so, in summary, I'm out of time. There's the whole idea of the ACI Anywhere, the whole vision is not just making your hybrid cloud work, but it's also much more than that. What I didn't get to cover, and I'll cover in about a minute and a half here, is all the other features we have, right? So we have had trust stack integration with ACI for a long time, right? So in other words, we can carry that security group membership from when you logged in and apply the policy to that into your data center. And it's been around for a little while. We have integration in 4.1, we're going to have integration with Tela as well as part of this whole process. So you'll be able to also optimize your WAN traffic. We have titration integration that we've had for a long time, right? We've got App Dynamics integration with ACI. So the idea is not only will you have, and then the last slide, how we're going to do it in Azure, right? So it's very, very similar. They're different constructs, but once we sort of get it right in AWS, and again, it's going to be in alpha very soon, then we're hoping that translating it into Azure and Google Cloud will be a little bit easier. And we already have an answer for your bare metal cloud stuff, right? So we have vPOD, we have remote leaf. You can extend your architecture across and basically apply policy and security across your campus, your data center, and your hybrid cloud.